Good afternoon. This is Math with Mr. Samuels. So just like with all the other videos, you need to make sure that you have your notes. If you do not have your notes, you can go ahead and press the link down below and print the notes out and make sure that you are following along with the video. At the end of this video, you are going to practice all of the notes, all of the practice problems on your own. And just like we did with all the other ones, we're going to go over them in class, answer any questions that you might have had. So let's go ahead and get started. Scientific notation. What is scientific notation? Well, scientific notation is a compact way of writing very large or very small numbers. And a number written in scientific notation has the form a times 10 to the nth power, where a is greater than 1 and less than 10. That's something that is very important. This number that we have, or the number that we have out front, must be greater than 1 and cannot be greater than 10. It has to be less than 10. Okay, you will see exactly what I mean when we do a few examples. So, how do we convert a number to scientific notation? Well, first and foremost, we need to locate the decimal, and then we need to move the decimal to create the new number, so to make sure that that new number is anywhere between 1 and up to 10. Okay, write using a power of 10. The exponent matches the number of times the decimal was moved. If the decimal was moved left, the exponent is positive. And if the decimal was moved right, the exponent is negative. Okay. So we're going to do a few examples down at the bottom, and then you're going to practice this on your own. So right now we have the standard form of 540. Right now 540 is written in standard form, but we're going to convert it and write it in scientific notation. So if this were money, $540, decimal will be right here. So what we need to do is we need to move our decimal to the left in order to make this 540 a number between 1 and 10. Well, let's see how many times we need to move that. Let's see how many times we need to move that. Well, if the decimal is right here, if we move it once, it will be 54. And clearly 54 is not a number that is between 1 and 10. So let's start back at the beginning. We're going to have to move it 2 places. If we move it 2 places, we end up with 5.4. And 5.4 is a number that falls between 1 and 10. So as a result, that is what our new number is going to be. Okay? It's going to end up being 5.4. And since we moved our decimal 2 places, we're going to have 10 to the second power. Now, once again, I want you to be reminded that right now I'm using the caret to represent an exponent. You all know that since you're writing on pencil and paper, you are able to go ahead and write the exponent out normally. You do not have to use this caret, but just want to make sure that I point that out to you. Okay, let's go ahead and do 2 more examples. Let's do 2 more examples. So we have 937,000. Well, if 937,000 were money, the decimal will be back here. So what we need to do is we need to move this decimal a number of places to the left in order to make sure that this number is between 1 and 10. Okay, so if I move it 1, 2, 3, 4, 5 spaces. Okay, if I move 5 spaces between this 9 and this 3, then I have the number 9.37. 9.37. And you have to ask yourself, is that number between 1 and 10? Well, 9.37 does fall between 1 and 10. So what we want to do is we want to go ahead and write that number in scientific notation. And when we have 9.37, okay, notice just like on the last one, I didn't write that 0 at the end. You don't have to write those zeros. Those zeros can fall. We don't have to end up adding those zeros. But we have 9.37 times 10. And remember, your exponent is always how many times we moved our decimal. So if we count, we moved it 1, 2, 3, 4, 5 spaces. So as a result, this particular example is going to be 9. Oh, let me redo that. We have 9.37 times 10 to the 5th power. Okay. So you're going to practice the rest of these on your own. But before we continue on, I want to do an example where we're changing a small number to a larger number. Okay, so let's look at this example down here. Okay, in this example down here, we end up with 0.00982. 0.00982. Well, right now the decimal is right here. So we need to move this decimal to our right so that we have a number that falls between 1 and 10. So we move it 1, 2, 3 spaces. Okay, if we move it 3 spaces, we will end up with the number 9.82. And then the next question you need to ask yourself is 9.82 between 1 and 10? Yes, it does fall between 1 and 10. So as a result, we're going to go ahead and write this number in scientific notation. So once again, we moved it 1, 2, 3 spaces, and the new number we have is 9.82. And times 10, that is always the same. And now we need to ask ourselves, how many spaces did we move our decimal? Well, our decimal was originally here. We moved it 1, 2, 3 spaces. Now notice, up here we moved our decimal to the left. And when we move our decimal to the left, we have a positive exponent. But now we moved our decimal to the right. And so now we're going to have a negative exponent. So we moved it 1, 2, 3 spaces. So this is going to be 10 to the negative third power. Okay. What I want you to do is go ahead and practice these problems. Practice the rest of these problems on your own, and then we are going to discuss them in class tomorrow. So now, when trying to identify whether or not a number is correctly written in scientific notation, we need to ask ourselves 2 things. First, well, really, we need to ask ourselves only one thing. Is the number that's out front between 1 and 10? Does that number fall between 1 and 10? Okay. If it does not, then clearly that number is not written in scientific notation. If it does, then we probably have a number that is written in scientific notation. So let's do an example really quickly. Okay. We have number 11. We have 2.98 times 10 to the 7th power. Well, let's ask ourselves, does this number, let me underline it for you guys. Hold on one second. Does this number does this number fall between 1 and 10? Okay. Yes, this number does. 2.98 does fall between 1 and 10. So is this first one written in scientific notation? Yes, it is. Okay. So go ahead and practice the rest of those, and then we will discuss them in class. So now, not only will we be able to convert numbers written in standard form to scientific notation, but we also will be able to convert numbers from scientific notation into standard form. And I'm going to show you how to do that right here. Well, if we read the instructions, converting to standard form is even easier. The exponent tells you the direction and the number of places to move the decimal. So we have to look at the decimal. We have to look at the exponent. And the exponent tells us how many spaces we are going to move our number. So let's do the first example. We have 6.38 times 10 to the third power. 6.8 times 10 to the third power. Okay, 6.38 times 10 to the third power. Well, that's a positive 3. And when I think to my head, which way are the numbers positive on the number line? Well, they are positive on the right side. So we're going to move our decimal 3 places to the right. So we move it 1, 2, 3. Well, notice that we have an empty space there. We will have an empty space. So since we have an empty space, we're going to add a 0 there. So we end up with the number 6380, which is 6,380. Okay, once again, let me do that for you one more time. We start where the decimal is, and it says move it 3 spaces to the right, and we move it 1, 2, 3. Well, notice we don't have a space in between 8 and the last space that we moved, so we're going to add a 0, and that 0 is what we have, 6,380. Let's do another example. Okay, let's do another example. So now this one says 2.085 times 10 to the 5th power. Well, since it's a positive 5, we're going to move our decimal place to the right. So we start at the decimal, and we need to move it 5 spaces to the right. So 1, 2, 3, 4, 5. Well, this time we end up with 2 empty spaces. So now that means we're going to add 2 zeros at the end. So the final answer should be 208,500. So let's go ahead and read this number back. This number is 208,500. 208,500. Let me go ahead and do an example for you with the negative exponent. And then just like all the rest of the problems, you will be responsible for doing the rest on your own. So let's do number 20. We have 5.25 times 10 to the negative fifth power. Well, since it's a negative exponent, we're going to move it to the left. Which direction are the numbers negative on the number line? They are negative to the left. So we're going to move 5 spaces to the left. So 1, 2, 3, 4, 5. Well, notice we have a number of spaces that need 0. So this is what we're going to end up with. We're going to end up with 0.0000, and then we have 525 at the end. Okay, so go ahead and complete the rest of your notes. Down here, you are converting these numbers from scientific notation to standard form, and you're going to compare them using a less than or greater than symbol, and you're going to do the last two on your own. That's just applying them to real world scenarios. We are going to discuss all of these problems in class tomorrow, and we're going to make sure that we have a complete understanding of scientific notation. So make sure you practice these problems on your own, all the extra practice problems on your own, and we will post the answers and discuss them in class tomorrow. This has been Math with Mr. Samuels. Have a wonderful day.